Alrighty, so I don't want to talk about WebWork 10 today, because I want to ideally maybe like have a shorter class, like just get done at 3 and just like, let's get the hell out of here and start break. But WebWork Final, WebWork 11 opens up. This will be the last graded WebWork. I am going to create some extra credit WebWorks. I haven't done those yet, but I'll like get them done and get them up. And they're going to be like review assignments. Like, if you want extra credit, you have to remember stuff that happened in September. so they'll have to go back and remember how to integrate stuff, and there'll be a series of them kind of like reviewing things, but they'll be worth doing. Yeah, that'll be that, and then we'll get back next week and we'll start on the home stretch of stuff we need to talk about. So, final thing before the break, and like our last major series stuff is a type of series that's not on the sheet. Alternating series. You guys have an exam in there today or something?
No.
Oh, okay.
I didn't even go.
Okay. Cool. Gotcha. I'm glad you're here. That's good.
Me too.
Alrighty, so alternating series. So an alternating series is one that alternates sign. Plus, minus, plus, minus, plus, minus. And they're really kind of nice. So it would be something that looks like this. You got A1 minus A2 plus A3 minus A4 plus minus. And all these terms, the A sub n's, are all positive numbers. So I'm assuming, so that if there's a minus in here, this couldn't be a plus because A2 was negative or something weird like that. And then, you could write this out in a general way. We could say n equals 1 to infinity, -1 to the n plus 1, if I want the first thing to be positive, A sub n. So just kind of writing that out in that way. These are really wonderful and easy to deal with. And here's the idea. If I have an alternating series, I can think of it with really cool steps. So let's think of the partial sums. So the first partial sum's just A1, so mark that off. There's A1. And then S2, the second partial sum, is A1 minus A2. And since A2 is a positive thing, I'm moving backwards that far. So I subtract minus A2, and then I end up here in A1 minus A2. So I go back that far. S3 is A1 minus A2 plus A3. So it's this previous sum plus a positive number. So then I move forward A sub 3. So this is, I'll just kind of write them out like this. Here's S1, here's S2, then here's S3. And I've gone forward A sub 3, I went backward A sub 2, and this first thing is A sub 1. And if the terms, if the A sub n's are decreasing in size, and they're also going to 0, so they're dying out, they're slowly decreasing to 0, what I'm going to see is something like this. There's the next sum, then here's the next sum, and I'm going to see this kind of honing in on a certain value. Does that make sense? Yeah. And then this number, they converge to something right here, and then this is the sum, right in the center. This is the alternating series test. So that's really lovely. So let's write that up. The alternating series test is not on your sheet of tools, but it should be. So let's abbreviate that AST. And so, given an alternating series, and we're going to write this like this. So -1 to the n, A sub n, or it could start with a different parity When I say parity, I just mean like where the pluses and minuses fall. It might start negative, it might start positive, it's all good, doesn't matter. It converges if the a sub n's are decreasing. So you think of this a sub n's as a sequence of terms. If the a sub n are decreasing, and I'll put a little bullet point here, and the a sub n's are converging to 0. It's possible to decrease but not go to 0. I mean, I could do something like this. Think of a sequence that, say that's 1 right there. You could go like this. You could decrease to 1. We want decrease to 0. So we just need to check these two things. If it converges, if this and this happens. Those are super easy to check. Let's actually do an example. And you're gonna like another part of this because it's like a school game where you like know this is always gonna be true and you don't have to like the decreasing part. Like you're supposed to check that, but if you're given one, it's always going to be true. So like you know the answer to this part right off the bat. It's the other part you'd probably have to show. So let's do an example. This is called the alternating harmonic series. This is the alternating harmonic. I swear to God, part of my shtick is like starting with a bad pen every day and then having to get a better pen. Like I like someday I'll stop that part of my little teaching show here. That'd be good. But here we are anyway. So alternating harmonic series. Remember that this was the harmonic series. So recall, and you should just know this one. This comes up in all sorts of places, that this one was the normal harmonic series. Did this converge or diverge?
Didn't do anything, right?
What's that, Lou?
Didn't it not do anything? It did like this.
When you say not do anything, what do you mean? Like it just eats chips all day and watches TV? Like we're all gonna be doing maybe one of the days coming up here, I hope.
Like it
Soon?
did like a little, it did like this thing, right?
Oh no, you're thinking of like the -1 + 1 series. So this one here, let me.
Does it diverge because it doesn't go up fast enough or something?
That is correct. It doesn't die out fast enough. And if I wrote it like this, what kind of a series is this? It's a P series with P equals what? 1. So this is a P series, right? Because you have that little P there. So this is a P series. P equals 1. And so what does that mean? Diverges. So the harmonic series is the borderline for P series, right? If we have this, let's just talk about some things while we can. If I have this converges if P is bigger than 1, and it diverges otherwise. And that's on your toolbox sheet that I've got for you, which I would have out when I'm doing series stuff, right? Have your toolbox. You're going to work on the sink, get your toolbox there. So this is the borderline between converging and diverging P series, this one right here. This is the alternating harmonic series. Let's see what it does. So it's definitely alternating. And if I write out the sum, it's going to look like this. Actually, could you do me a favor? Could you write this out, please? What does that series look like? Take a moment, write that out. Let's practice that. do like the series hanging out eating chips and stuff, though. Somebody help me out here?
I said -1 overhand.
So you said this here, Josh?
And then to the end plus 1.
Aha, yes, sir. Thank you. Beauty. Love it. So make sure, so notice how Josh adjusted the exponent here so it started on a +1. So when n equals 1. You could do this in another way. Let me just show you really quick. If you like starting your series at 0, there's nothing wrong with that. No one's going to crack down on you. But you just got to make the right adjustments. So either one of those is totally cool. Just make sure things are in sync. All right, so we've got an alternating series. When you have an alternating series, you want to just pull out the non-alternating part. So pull out the non-alternating part. And that's this. That's just this. And all the analysis takes place on this. So is this decreasing as n gets bigger? Yeah. Didn't sound super confident, but you're totally right. As n gets bigger, this goes down. How could I prove this was decreasing? What? Plotting? Oh, plotting is beautiful. Yeah, I could plot it. How could I use calculus?
Take a limit,
Take a what?
a limit.
The limit only tells us far out what's happening. It doesn't let us know that everything's always decreasing. So, right. Yeah. What were you saying, Vivian? The question is, how could I use calculus to show this is decreasing?
Can you do the integral test?
Ratio?
I think Calc 1. Calc 1, how did you show a function was decreasing?
Oh, derivative.
Derivative. I can take the derivative. What does the derivative have to be a decreasing function? Derivative slope, right? What do you want the slope to be? Positive, so that it goes up. Negative, so that it goes down.
Negative log?
No, just good old derivative. Well, check this out. We got all sorts of ideas here, but we're missing the most simple one of all. So if I look at this as a function of n, like this, I could take the derivative, which I know you could do that using the power rule and some time. Let's just say we did it. Why is that always negative for n? So when n is, so these are the n's we got. Why is that always negative? You might be looking for a deep, because it's negative, right? Because like n squared is a positive thing. There's a negative in front, that's less than 0 here. So f is decreasing. If you were pushed to explain yourself. Otherwise, I like Cassie's answer, just plot that shit out. See the dots going down? There's a decreasing. That's you don't see all the dots, so that's the problem with that. It's like, well, I see 10 dots, they're going down for those 10. That's good enough.
But I mean, if it's a series, then it wouldn't just randomly change.
This is true. There's some, you're right. If a mathematician asked you though, they would want this like solid proof. Oh, here's a good way to do it. Oh, check this shit out. Which one of these two is bigger? That's right. The one with more. What happens when you take the reciprocal in an inequality? So when I have 3 is less than 4, how does 1/3 relate to 1/4?
1/3 is bigger.
You flip it, right? When you reciprocate things, you flip the reciprocal. So that shows it's going down too. There's another way. I just want to show this and like we'll never do it again. Okay, so like here's the thing. If you're doing the alternating series test like on all the web work problems in number 11, you probably don't need to show it's decreasing. Okay? That's not where things are gonna fall. In fact, it's really hard to make a series where it's not decreasing and it matters. Like I thought about it and I was like, I don't give a shit. So I know you won't. So, decreasing, yes. Of course it is. You asked me. You asked if it was, so of course it is. All right, yes. Always in here. See, it's all good. Everything's safe. Now this other part, the second condition, does a sub n converge to 0 as n goes to infinity? Does that happen? What is the limit of 1 over n as n goes to infinity? Please tell me you know that. 0, thank you. Oh, couple of zeros, yes, goes to 0. That's the thing that's gonna matter. If that doesn't happen, the series will not converge. So by the AST, alternating series test, that series converges. Yay. But if I slap absolute values on it, it gets befouled. Just befoul is just a word that people should use more often, I think. That's a good word. You befouled this. So it's befouled if we put absolute values on it. In other words, so absolute values on the terms. In other words, remove the alternation, i.e. remove the alternation, the plus minus. That's plus minus, not some, I don't know, that could look weird. So when I take off the plus minus, what does that series turn into? So if I take this series that Josh gave us, what does that look like? Pretending to fix my shirt up here. Well, I'm ready for dinner. What's the answer?
Isn't
One
this,
plus.
isn't it the same thing but no negative?
Yes, I think Lou's saying that.
Yeah.
I think. It's just this. Yeah?
Yeah.
So,
Yeah. Right? Because -1, absolute value of it's just +1, right? It just takes off the damn plus minus. It turns it into what series? Harmonic. This diverges. So, this series is called conditionally convergent. So let's put a little definition here. If the series converges, but when you remove the alternation, so notice I'm just pulling off the -1, but the series without the alternation diverges, the original series is said to be conditionally convergent. If you put the absolute values on and everything's still okay, it's called absolutely convergent, which was on the damn web work, but we didn't talk about it. Yeah, so I apologize for that. So if this converges without the alternation, is absolutely convergent. Which makes sense, the absolute values are there, absolutely convergent. Alrighty, so let's take a look at another one. Oh, let's do this. This pen's dead. You know what I'm gonna do over the break? Get some new pens. Go steal some from a good room around here. So,
Dr. Sheep, I have a
yeah,
question.
yes.
It's not, it's kind of not relevant, but it
Oh,
kind
God.
of is.
Okay.
Did you ever have trouble writing the sum symbol at first?
Oh my
Yeah.
gosh.
Yeah.
Does anyone else have trouble writing it?
I always
Yes.
accidentally try to make it neat.
It does, and like you can see that it's starting to devolve in some ways, right? Like I think that a lot of times people do this, gets like a sideways M kind of thing.
Mine's neat, the first half, and then the bottom half is kind of ugly.
I always
Little
think
line
I
on
get
it
so
anymore.
frustrated sometimes.
Yeah,
Like,
me too.
what is that?
Sideways M, sideways capital M.
I just draw it like that. I don't know.
That's
the
good.
little things on
That's
it.
great. That's great. Yeah, you don't need to have these like serifs or whatever on here, you know. It's all good. If you could just, hell, you just write this, I'll be happy. As long as you know what you're doing.
Can you write the lowercase sigma?
No, that's special. That's like standard deviation and other things.
That'd be so
Only
easy.
capital. Only capital. But yeah, you don't, I like that, Cassie. You don't have to do that. That's great. Does this help? Like just doing that?
Yeah.
Cool.
I didn't think it's always gonna look funky.
Yeah. It's a learning process. I know. It's all good.
I was talking, sorry.
That's okay. No, go on. What are you gonna say?
Well, I was like, I don't know how my professor does it so good. I was on the phone with somebody and they were like, well, he's probably been doing it for years. And I was like, that's so true.
Yeah. I've been doing it for Jesus Christ.
What about a cursive E? A cursive?
56. Started studying math. How old are you guys? I don't know. 26, 26.
I'm old, thank you.
At least 30 years I've been doing it. How about that? Plus.
Can you draw it like an uppercase cursive E?
It's gotta be straight. It's gotta have those corners in it. I'm sorry. What do? You like this?
Yeah.
No. It's like McDonald's. We're not
So we can't have it our way.
That's right. That is correct. Awesome. Need a symbol. Good one, Jesse. Where are we? Oh God. Okay. So, all right. That's an n squared. And we'll start at 1, infinity. Can you do me a favor and tell me if that series converges? Let's take a moment. So first, remove the alternation. So remove the alternation. What does the a sub n look like without the plus minus, plus minus? It's up here, right? Yeah, so when we took off this, so when you, like, just what is the non-alternating part? Yeah, so basically remove.
It's this.
Yes, so write the general term with just to replace the -1 to make it +1 with 1. That's the, yeah.
No, yeah.
Okay.
But then is that not harmonic?
No, it's not harmonic.
Oh,
Correct.
okay.
That is correct.
You know, if we were still dealing with that.
Why do you remove the n+1 up top?
We'll say that again.
So why do you remove the n+1?
because, so the alternating series test was this. N or N plus one here, oh shit. It's all about the non-alternating part. So we grab that part. It's almost like you're taking the absolute value of it to do the analysis. But it's that these things that we're plussing and minusing get smaller.
So taking the absolute value removes the n plus one.
Yes, sir.
Okay.
Well, yeah, I mean, it removes the whole -1 complex up here, right?
Okay.
So one way to think of it is, that I was just telling Lou, just replace that with a 1.
Isn't that just because anything to the power of 1 still equals 1?
True, yes.
That's what I
Gotcha.
thought it was, why it went away.
That worked too. Did we feel good on that?
Yep. So you wanna just grab the non-alternating term. Is this decreasing?
Yes.
You know it is, because I asked, right? So of course it is. But you can see that as the bottom gets bigger, this fraction gets smaller. I don't think that's crazy. If you plot the dots, they go down. So a sub n is decreasing. I'll just use that little shorthand, check. What's the limit as n goes to infinity of a sub n?
0.
0. Fixed thing over something blowing up, right? We've been here like every day. Every damn day that happens in this class. So, check. So by the alternating series test, the series converges. So now I'm gonna ask you, does it converge absolutely? Does it converge absolutely? Yeah, why? What does it look like without the alternation first off?
It looks like the 1 over n cubed.
Yeah, it's beautiful. And why does that converge, Cassie? You're right.
Because they're both the same without alternating. They both decrease.
But this one didn't. So this one doesn't converge, right though?
Because of the squared it does.
Yes, what kind of a series is it? Your
Series.
P series or P's too. Yeah, so that's the reason we want to give here. You're totally right, your intuition is telling you the right thing. So this is yes, because this is what it looks like when I replace the -1 to the n with just a 1. I take the absolute value, because this is just a P series with P equals 2, which is greater than 1, and that's what a P series, when a P series converges. So this series is absolutely convergent. Unlike the last one, the alternating harmonic was conditionally convergent. This is absolutely convergent. Let's do another one. By the way, I've trimmed a number of problems off of web work, the final web work. So it's like only 10 problems long, as opposed to the 14 or something like that. Originally had, so happy Thanksgiving. Here's one for you. Take a moment. Converge or diverge? What's a sub n here? What's the a non-alternating term? N over n plus 1. Does that converge to 0? As n gets, it does not. What does this converge to?
1.
1. This converges to 1 as n goes to infinity. So this series diverges. So that breaks the second rule of the alternating series test, but it also is that nth term test. The series has to die out no matter what. So there's two ways you can see this. It breaks the nth term test or it breaks the alternating series test. So this series does not converge because we need the terms to die out at a minimum. Cool. And I think there's at least a couple like this on the web work. So keep a look out for it. There's one last thing I want to talk about with alternating series. And then we'll take some time to just like work on it. So this whole idea where I had the series at the beginning. Remember how that went? We had, Jesus. That's right, I can throw things with precision. Only pens. There we go. All right. Semi-precision, I guess. So S1, partial sum 1 is just the first term. Partial sum 2 is A1 minus A2. I'm just going to write this out again because it never hurts to see this too many times. But what I really want to point out is this picture again. So the first term gives me an upper bound for how large this sum could be. Because if this thing's going to converge, then A2 is going to move me back to here. So here's A1 minus A2. So right, I subtract off A2, and I'm here. Now I know the sum lives between these two things, right? So the final answer is just going to be bouncing back and forth. So I know that the true sum lives between here and here. And I know that all the way every time I make a new step. So if I now add A3, so here's A1 minus A2 plus A3, I now know the truth is in here. The true value is between those. Wow, true veil. It's like some kind of place in a vampire land or something, doesn't it? I don't know. Yeah. Anyway, true. Yeah, I'm ready for the break. But the true value is always between the current partial sum and the next partial sum. So what I'm trying to say here is that the true value of an alternating sum is always between any two partial sums. No matter what n I got. And these two things are going to get closer and closer the further I get down the line. And I want you to think about something else. That if I'm here, so let's say, one more picture. So let's say, oh, you bastard. Why are you doing this to me? Oh, I don't know. That's not that great either. Oh, shit, I hate using the red ones. Why is everything so challenging? At least I don't have to mess with the lack of Excel on our Regis machines. Come on, baby. There you go. Okay, just give me 5 minutes, Ben. All right. So let's say I got this partial sum right here. That's an estimate of the true value. And I know that the true value is going to live between this partial sum and the next partial sum. What is the difference between those two? It's just this term right here. Because this guy is A1 minus A2 plus minus whatever up to the nth term. This is the sum of the first n things. Imagine I have n fingers. And then this one I add the next term. So the truth is in here. And so what I'm saying with that picture is that the nth partial sum minus the true value of the series is less than or equal to the next term, is less than or equal to the an plus 1 term. Now why is this important? Because I can figure out how many terms I need if I want a certain precision. So let's do one last example. Okay, so problem. Problem, I'm gonna just go with it. Estimate or find the number of terms needed to estimate this sum. Let's do the alternating harmonic. N equals 1 to infinity. So that's just the alternating harmonic, no matter how shitty it looks and how poor this pen is performing, to within 0.001 of its true value. You got a couple problems like this on the web work. How many terms do I have to go so that I know that, yeah, this thing's only 1,000th away from the true value? So the method is this. Here's your step-by-step process. 1, find the a sub n formula. In other words, just pull off the alternation. So here it's just 1 over n. We've done that a bunch. Pull off the minus 1 to whatever power. 2, use that, find an plus 1. So that's literally just take that and replace n with n plus 1. Now it might be more complicated than that in some places. Set an plus 1 less than or equal to your tolerance, your given tolerance. So here, it's going to be an plus 1, I'm going to set it less than or equal to 0.001. And solve for n. So this is 1 over n plus 1 less than or equal to 0.001. Solve, so step 3 is solve for n. How do I solve this inequality? Take the reciprocal, right? Yeah, beautiful. That's gonna happen almost every time. Take the reciprocal. Cassie says take the reciprocal. And Cassie also told us to flip the sign before, so I'm gonna do everything she says. What's the reciprocal of that? What is that in fraction form?
1 over 0.001.
Yeah. What is that? What, so this is 1 over 1,000, right? So its reciprocal is 1,000. So subtract 1 from both sides, n must be greater than or equal to 999. I have to literally crank out 999 terms there and add and subtract them to get within 1,000th of the truth. We're not going to have to do that. But that's what I need to do. And that's, so you've got a couple problems where it says how many terms do I need? And then you could write a piece of code to do it or just crank it out in Excel or something like that. But you don't have to. All you need to do is this. Let's do one last one, just practice. Let me ask you this one, just make sure you get it. So let's go back to the series we know converges. We had minus 1 to the n plus 1 over n squared. N equals 1 to infinity. How many terms of this do I need? So how many terms to estimate to within 1,000? Let's answer the same question, but for this series. Give it a shot. Follow the step-by-step procedure right there. We're in the restroom. Right back. Pounded teas.
For people to participate in the courses and stuff, and to have the classroom set up.
equals 1 over n plus 1 quantity squared. All right, good shit. So then, I'm going to set that less than the tolerance. So I'm going to set. Yeah? What do I do first?
Found reciprocal.
You can do that? Yeah, absolutely. Let's do that. I like it. And we know the reciprocal of that. It's already 1,000. Yeah. Now what do I do?
Square root.
Square root. Oh, shit. What's the square root of that? Like 30? I don't know.
Like 31 point
Was it-
something.
Oh, 31 point something? Yeah, that sounds right. 31.7? Something. It doesn't even matter really, but I kind of want to.
0.62.
6.
Yeah.
Subtract 1. So what's the first index that I can use? Because remember, n is a whole number. So n has to be really starting at where? 31. So don't forget to round up. 31 terms. Slightly better than this, still horrible. Nobody wants to do that.
If I could pick 31, then
I'd rather pick 31 than 999. But I'd rather make a computer friend. That's what robot friends are for. All right, let's actually start on the web work. I know we all want to go. I want to go. You want to go. Let's start on the web. Because we cannot spend Monday working on this web work, right? So I'm going to really implore you to try to get as much of these 10 problems done before Monday as possible. I beg of you. Thank you. It should be open now. Let's keep the film running. Be quiet with these. Okay, I just want to see what the first problem is. Okay. Does it make sense? Okay, cool.
One small question. So, I'm just confused about what's put here.
Just these. It's always between these two partial sums.
okay.
Yeah, so, yeah.
And then you just take this step.
Actually, you don't even have to do it. Just literally have to enter that one.
Really?
Try it. Because that's the n plus 1 term. What?
Variable n is not defined.
What? What the hell? Oh, n is 4. So okay, that's what's up.
Okay,
So
yeah.
just replace all your n's with 4s and everything will be hunky-dory.
You just really need to read things.
It helps. It never hurts, that's for sure.
This is the S of n, right?
Correct.
Then it's just one more.
What is that?
So just one negative one.
-1.
No,
Wouldn't
no.
this be
Oh,
5 now?
oh, wait, whoa. Okay, so actually, it's actually not that term. Let's take a look. Let's look at problem 1 together. So they are asking for S4, right? I think everybody, S4. So that's the partial sum of the first 4 terms. So they're actually asking you to do, what is that series? I think everybody has -1 to the n plus 1 over n factorial.
Yep.
Yeah? So, and we start at n equals 1, is that true? Yeah. So first term
Why just to
is
the n?
1. So that's S1, or S4, excuse me. Some of the first 4 terms with the alternation in there. And then S5 is that plus the 1 over 5 factorial.
So we have to put all those numbers?
Yes, you have to put in those 4 numbers.
I'm just making sure.
Yes.
Like, I don't have a
Yeah,
problem.
I mean,
Just making
it's
sure.
like, it's 1 minus a half plus a 6 minus a 24. This is not too bad.
What would the second part of it be? I'm kinda confused by that.
What are you confused by?
The second part of it?
Let me see.
Is that like the lines?
Oh, so that just wants these 2 numbers in there.
So
So
it's-
this one is, you're adding that on, so it's this sum plus 1 over 5 factorial.
For this one?
No, for this.
Oh, I know that, I'm talking
Oh,
about this
okay.
one.
Then whatever these numbers are, then just go
They
copy them
just-
down
oh,
here. Yeah,
oh,
yeah.
okay.
Mhm. Make sure you put the smaller one to the left. Yeah.
Oh,
Oh, you're doing good though. Yeah, it should be the sum. You want the whole partial sum in here, Lou. That's the problem. So this plus 1 over 5 factorial. That whole thing, yeah. Plus 1 over 5 factorial. Yeah. And then those numbers get copied down in here again, those 2 new numbers. There you go. There's, I see greens already. Kind of, oh no, lots of old green. Yeah, okay, good. Are you still getting it under there? Yeah, how's it going here? Good. Lots of green. Nice. I do need. Yeah, so yours starts, yours is just the negative. You put parentheses around the whole thing and plop a negative in front of it. You might have to change who's less and who's more though. Yeah. I do, David.
Plus.
Yeah, you're still entering stuff, right? Let me see what you're entering here. Oh, you are. You're getting there. Yeah. Josh, you doing okay?
I'm not sure yet.
You'll find out soon, right?
Lots of reds.
Yeah, lots of reds, that's okay. Tweaks. Everything okay?
So you put that what we did over there on this one, and then I just added the term.
So careful, yours actually starts at negative.
Oh, that's.
So you need to change the signs in between,
Okay.
and then you'll probably need to flip these two, cause they'll, yeah. Does that make sense?
Yeah.
Yeah.
Thank you.
Yes, sir.
So, I thought I needed to put this on too, but,
You do.
well, they started at negative, they were negative.
Well, I don't know that was what was wrong. So let's take a, so look, check it out here. Slow down. So when n equals 1, you got -1 over 1 factorial. So your first number is negative. So it's -1, and then it turns to +1 over 2 factorial. There you go. And then, yeah, then we got plus, so that sounds good. And then that number's probably, I would cut and paste that all, because that's gonna be the bigger one, right? Yeah, and then do the -1 over 5 factorial on the left. No. Oh, wait, sorry, yes, sir.
Yeah.
I'm sorry, I was looking down here. Yeah, you're right, Josh. Give it Yeah, that's gonna go there, and that's gonna go there.
And what is the L for this?
And then that's the n plus first term, so that's the 1 over 5 factorial. Yeah, check it out. See what there we go. So the difference between that s sub n and the true value is just that last term that you added on. Yeah.
Okay, thank you.
Okay. I see green. Oh, sorry. I'm sorry. So that's that last term. So what is the term that you added, that n plus first term? So here was s sub 4, right? And then, oh, yeah, okay, here was s sub 4. And then here was s next, the next. So that, the term you added on to get from here to here is the difference between, remember in that little thing that I had on the board, it was the difference between the nth sum and the true value is less than the nth plus first term. So that's the 1 over 5 factorial piece right here. Does that make sense?
You have to flip that or change the sign. It's only one number, the last one.
Oh, yeah,
And then
it's
you
just,
have to flip the sign.
it's just that term, that 1 over 5 factorial, not the whole sum. Yeah. Yeah, it's just the 1 over 5 factorial. It's the next term. No flip. Why do you think?
You have to change the sign, because it's minus.
Oh, yeah, you have to make it positive, yes. It's
So
the
I
non.
didn't realize that.
Okay,
at first.
gotcha.
I just like tried.
Yeah, so just 1
negative, I was
over
like,
5 factorial. Yeah. Okay. Yeah, number 2.
Yeah. And it's just this. Yeah, I'm trying to find the square root of 4,000.
Oh, okay. That's cool. That's cool. And then round up, always round up, yeah. Yes, ma'am. So the sum, the true sum, and this is the nth partial sum. So this is that thing where I was, how many terms do you need? So you want to find the n plus first term without the -1 part on it. And then, so that, just like that stuff I was doing on the board where I got the n plus first term and set it less than this tolerance. So we've got, what is the n plus first term gonna look like without the -1 stuff? Let's find that. So first off, what's just the nth term look like without the -1? What is a sub n?
Yeah, beautiful, so we write that down, and we set that less than or equal to, or just less than this tolerance here, and then solve for n. That's the n they're looking for here. And then the sum, it shouldn't be too many terms, they want you to actually take plus, they want you to actually crank out that many sum, partial, that many terms, and figure out what they add up to. But it should be very few, I think, we'll find out together here. Doing all right? Okay, awesome. Very good. Nice. How you doing, Cassie? Doing all right?
That's looking good. These numbers are looking good. Definitely numbers, that's for sure.
Computations look good.
Good, give me something to do. Your shoes look super warm and toasty.
They are.
Yeah.
So for this one, what are you doing with the 10 negative 4?
So we're gonna set this less than that 10 to the negative 4, and then solve for n. So yeah, let's do that. Yeah, exactly. And then do the reciprocal.
Couldn't you just, isn't it easier just to do like this on both sides? Or the reciprocal is easier?
I think the reciprocal is easier to go, yeah. Like, I wouldn't cross multiply, which I think is what you were doing there.
So, when you do the reciprocal, why is it that this becomes 1,000 if the reciprocal is 0, 0?
Because this is 1/1000. It's 1 over 1,000. And the reciprocal, see, that's why the reciprocal is way easier.
Okay.
You see, so this is 1 over what?
10
Yeah, so. Well, yeah, you're doing great. Yeah, you're doing great, yes. And that's still the 6th power, so be careful there. So look, Leslie, you can make this is 1 over 10,000. What's the
So just
reciprocal?
10,000.
10,000, yeah. That's good. And then there's still n plus 1 to the 6th, yeah. Now just take the 6th root of each side. Yeah, that's definitely a calculator. And since, one last thing, sorry, since you reciprocaled, you want to, it becomes greater than or equal to, yeah. There you go.
good. Just take the sixth root of both sides. You're gonna have to get a calculator out and find the sixth root of 10 to the 5th. Yeah, or the 1/6, like 10 to the 5/6. Does that make sense? Yeah. Whatever that is. So yeah, so they're asking for the next whole number. After you solve for n here, they're looking for that right here. They're asking you to actually crank out the sum to that many. And it shouldn't be very big at all. Like, yeah, I gotta find out what 10 to the 5/6 is myself.
Wait, so what is the one for the S?
So for that one, they want you to, so what is your, let me see your sum.
I think mine's different because everyone else is 10,000. I think I'm.
Oh, you got lucky.
Oh, lucky.
You got So, yeah, so like everybody's just kind of like this. They're not like ripping on you, Josh, with this problem. Man, that's horrible. But so like say, so which problem is this 4? Yeah. Let me do one kind of like it. 10 to the 5th. Okay. 10 to the -5th. So in this one, your a sub n plus 1 is just this thing here with n replaced by n plus 1. Everybody seems to be doing that okay. And then you're going to set that, so Joshua's is less than 10 to the -5th. So when you take the reciprocal of each side, you can just make that exponent positive. And so that's pretty awesome. And then take the 4th root of each side. And so 10 to the 5/4. I don't know what that is. More than 10. Oh, this would, yeah, yours is gonna be nicer than this because your exponent was, actually your power was like 6 or something,
Yeah.
right? Yeah, so this will work out better. The one I'm working out,
Mine was 6.8.
what was it?
6.8.
6.8 after you solve for n and you
Well,
subtract.
after software end, it was a total of 6. N was 6.
So you had 6 here, right?
Yeah.
And then, so you'd have something like this. And then 10 to the 5/6, what was that?
It was 6.8.
6.8?
And then I subtracted 1.
So 5.8, so n has to be greater than 5.8.
And then I said 6.
So 6. Oh, I see what you're saying. So you have to then take the first six terms here for the second part. So when they ask s is approximately, it's going to be 1 over 1 to the 4th plus 1 over minus 1 over 2 to the 4th plus 1 over 3 to the 4th minus 1 over 4 to the 4th 1 over 5 to the 4th minus 1 over 6 to the 4th.
So
That's what you have to find.
You
then.
want to alternate.
Yes, sir. Yeah, then the actual sum has the alternation, yes. So everybody's will kind of be like this, and that S that they're asking for is.
input it like that?
You probably could. Yeah, you could probably type it in just like this and you don't have to crank it out on your calculator. Yeah, which is kind of sweet. WebWork will do a lot more for you than I think folks let it do for them. We're staying the full period, but hey, we're getting stuff done. Less stuff to do over break, exactly. Josh, you're almost halfway done, right? Yeah, almost. And not all the problems are this brutal. Some of them are pretty straightforward, I guess. I think it's this one. This one. Everybody's on this one. Everybody's kind of cruising at the right rate. It's nice.
you some take-home stuff to do, so it's not all just like stressed out work. Right, stuff you can write up and have time, think. I'm gonna get creative with the final, make all our lives easier. Looks good, Cassie. Bright green. Yeah. It's like you sadly, like your endorphins probably start flowing now with green web work. No? Oh no? No? It just quells the rage.
I don't have rage.
I know. Okay, that's the end of this.